Imagine if I told you there's an AI that can hold the blueprint for every tiny machine inside our body, all the proteins doing their dance of life, and it cracked that code. Think of it as the Google Maps of our biological building blocks. What if I said this AI could save years of lab work, unlock cures, and give us ultra-powerful tools we never thought possible? Well, that's exactly where we're going today when we dive into AlphaFold, the most useful thing AI has ever done. Hey friends, welcome back to the channel. If you're new here, hey, I'm George. I've been doing tech and science videos for over 10 years, and I'm excited to break something down that isn't just cool tech, but might be life-changing tech for all of us. Today I'm going to explain AlphaFold in simple terms, show you exactly why it matters, and how it could be the tool that finally helps us solve some huge global challenges. Make sure you stick around because I've got examples, a little bit of wow factor, and by the end you'll see why this is not just niche science stuff, but something you should care about. And yes, I'll show you how you can even access or benefit from these tools. Let's roll. Alright, let's start simple. 1. What is AlphaFold? Proteins are the little machines inside our cells. They're long chains of amino acids. Imagine beads on a string. That string doesn't just stay flat, it folds and loops and spirals into a 3D shape, and that shape determines what the protein does. If you have a flat or misfolded protein, it might malfunction, like a car engine with missing parts. Historically, figuring out a protein's 3D shape has been ridiculously hard. It could take years of lab work, expensive equipment, complex experiments, but AlphaFold changed the game. Created by DeepMind, a Google Alphabet company, it's an AI system that predicts the 3D shape of proteins from their amino acid sequence alone. In other words, give it the string of beads, it tells you how the string folds into a machine. That's huge. 2. Why is that useful? Because protein shape, function. If you know the shape, you can guess what the protein does, how it interacts, how you could tweak it. Let's use a simple analogy. Imagine you have a key, amino acid chain, and a lock, the protein's target in the body. Without knowing the exact shape of the lock, you can't design the key properly. AlphaFold gives us the lock's blueprint instantly. Suddenly you can design the key much faster. That means new drugs, new enzymes, new materials, faster. One article said AlphaFold predicted over 200 million protein structures to date, nearly all proteins cataloged. 3. How does it actually work, in plain terms? Okay, I won't bury you in deep math, but let's break it down. You give AlphaFold the amino acid sequence of a protein. It uses something called a multiple sequence alignment, MSA. It finds similar sequences across many organisms, sees which amino acids tend to move together, co-evolve. It builds internal pair representations, how each pair of amino acids might relate in space. It then uses deep neural networks, the evoformer module, structure module, to iterate, predict a shape, check it, refine it. Eventually you get a very confident predicted structure. So think of it like a puzzle solver. You know the pieces, amino acids. You look at thousands of similar puzzles, MSA, you estimate which piece goes where, pair relationships, you build a shape, check if it makes sense, fix it, done. 4. Why is this a most useful AI moment? Because many big problems in medicine and biology were bottlenecked by the we don't know the shape step. With AlphaFold, you can know it quickly. A few use cases: drug discovery, designing medications that fit precisely to a protein target. Without knowing the target's shape, you're guessing. Now, you have the blueprint. Understanding disease. Many diseases happen when proteins misfold. With AlphaFold's predictions, researchers can spot misfolding problems faster. Agriculture, environment. For example, enzymes that break down plastic or microbes that help crops. Knowing protein shapes accelerates designing better ones. This is cited in DeepMind's site. 5. A simple example. Let's make it super concrete. Suppose you're making a new medication for a virus. You identify a viral protein that's essential for the virus to replicate. You know its amino acid sequence. We can sequence viral genes fast. You feed that sequence into AlphaFold. AlphaFold gives you its 3D shape. With that shape you can design a small molecule, a drug, that fits into a particular pocket of that protein, blocking its function. Without AlphaFold, you might have to spend months, years doing crystal structures. With AlphaFold, many of those months vanish. Another analogy. Let's say you're trying to repair a machine and you have no blueprint. You spend hours taking it apart, figuring how each cog fits. But if someone gave you a 3D blueprint right away, you'd fix it far faster. That's what AlphaFold brings to biology. 6. What sets it apart from old methods? Before AlphaFold, people used homology modeling, looking at similar proteins whose shape we already knew. Or experimental labs, X-ray, crystallography, cryo-EM. Those were slow and sometimes inaccurate. AlphaFold works even when no close template exists. That's a big leap. It achieved accuracy close to lab experiments for many proteins in competitions like CASP. 7. The impact so far pulls. What's next? We're already seeing the impact. Hundreds of millions of structures predicted, researchers around the world using them. It's accelerating biology research. DeepMind says the database has over 2 million users in 190 countries. And the next wave, we now have versions like AlphaFold 3 that predict not just single proteins but how they interact with other molecules. That means moving from what is the shape to what does it do when it meets this drug or that cell partner. This unlocks even bigger territory. 8. Why you should care and how you might benefit. You might think, hold on, I'm not a scientist. Fair point. But here's why you still care. Health. Faster drug discovery means sooner treatments for diseases you, your friends, your family might face. Tech and business opportunities. If you're into biotech, health tech, or even investing in those sectors, this is a foundational enabler. Education and awareness. If you're a creator, and you are, YouTube channel, etc., you can ride this wave by making content about these breakthroughs, building credibility. Tools. While AlphaFold itself is quite research-oriented, allied tools, data, and services are emerging. For example, you might use structural data to create content, visualizations, or even educational assets. So, yes, you might not be designing proteins next week, but you are living in the world changed by this technology. And if you're a creator, communicator, educator, or even just a curious person, this is a story you'll want to tell. 9. The commercial angle. Why this matters for business and tools. Because anything that shortens time and cost in drug development means huge savings, huge value. Companies and startups that adopt structural AI tools early will get a competitive edge. From an affiliate creator standpoint, there are software platforms, visualization tools, data subscriptions, training courses, and educational products centered around structural biology and AI. That means you can promote or use these tools and earn affiliate income, especially in STEM education, biotech, innovation. And by building content around this now, you establish yourself as a go-to. Imagine launching a digital product, how to visualize and monetize protein structure data with AI. People who are into biotech, education, students, even creators might buy. You could integrate data from AlphaFold-style predictions, create templates, visuals, explainers, sell a Notion or digital course. That fits your plan. Digital products via Gumroad, and leverages this high-interest domain. 10. My perspective. 10+ years in this game. Having seen many breakthroughs in tech, I can say, this one feels different. Why? Because it flips a core bottleneck, in this case, biology's biggest, the protein folding problem. When you remove a foundational barrier, you unlock everything above it. That's the kind of change you want to create content around, invest in, build communities around. So if you're thinking, which tool, niche do I build content on? Structural biology AI is part of the big wave. And yes, you can ride it by creating explainers, education, visual content, affiliate tools. If you found this fascinating, don't forget, I've dropped links in the description to try out some of the tools and databases related to AlphaFold and structural biology AI. Also, I've prepared a free AI toolkit you can grab, link in description, that includes visual templates, a Notion layout, and content ideas you can use for your channel or digital product. If you like this video, hit like, smash that subscribe button, and ring the bell so you don't miss future deep dives into AI tools that actually matter. Leave a comment. What would you design if you had access to protein-shaping AI? Think big. I'll pick one comment to feature in the next video. And check out the next video here, point to next video card, where I'll show 5 AI tools you can use today to create a biotech side hustle. You won't want to miss that. Thanks so much for sticking around. I really appreciate you being part of the journey. This stuff matters. It might sound deep, but at the end of the day, it's about life, health, and making the impossible possible. I'm excited to see where you take this. Until next time, I'm George, for the channel, saying, stay curious, keep building, and I'll see you in the next one. One last question for you. If you could use an AI like AlphaFold to solve one problem in the world, which would you pick? Drop it in the comments. I'll be reading. Bye for now.